Welcome to this next edition of the eVTOL Writers Group interview. Today we have an all-star cast from CAE here to talk to you about pilot training and the needs, especially as it relates to the eVTOL landscape. We also have a fantastic moderator in Ken Schwartz, who will be leading the discussion question and answer period afterwards. Ken is a longtime media and communications consultant for the aerospace industry, and is a board member and the director for the VFS Americas region. So Ken, I'm going to go ahead and turn it over to you to kick us off.
Okay, welcome everyone. Delighted to be hosting this webinar today for the VFS eVTOL Writers Group, and delighted to be focusing on a topic that really has not been top of mind at the conferences and events over the last few years, but certainly is going to play an important role in the development of the eVTOL industry. So the title of the presentation today, as you can see on the slide, is an innovative and data-driven approach to building the aviation workforce of tomorrow in advanced air mobility. Presentation abstract that everyone should have received. I'll just quote the first part of it. We're at the cusp of a new era of aviation, and with this new era comes a new demand for uniquely trained professional pilots to safely fly passenger and cargo at scale across the globe. Well, most attention in the field of advanced air mobility has focused on advances in electric propulsion. Sources of power and infrastructure avoid exists in the narrative of pilot training. Today, we're delighted to have two representatives from CAE speaking on this topic. Now, many will be aware of the name CAE, but just to provide a little bit of background, CAE was founded 74 years ago in Montreal with the original name of Canadian Aviation Electronics. The history of the company really integrates two different industries: the history of and development of aviation, commercial, military, rotary wing, business aviation, and the evolution of electronics. So the story of the company really is sort of at the nexus of these two technologies, aviation technology and electronics technology, advancing over the last 7 or more decades. CAE is well known as a flight simulation company. The beginnings of that were in the 1950s when they built simulators for the CF-100 jet fighter in Canada, and then the CF-104 starfighter. They built simulators under license for commercial aviation in the 50s, but in the 1960s became a OEM developing their own flight simulators and became really the leading manufacturer of commercial flight simulators in the world. 20 years ago, they also pivoted into the training industry, standing up training centers around the world, taking over management of training centers, and also entering the ab initio training world for civil aviation. The linkages over the last 20 years have been tremendous. For those that have followed the company, they're also very active in military training and simulation. And in fact, over the last year and a bit, during COVID-19, they've invested over $1 billion in acquisitions. Now, today's topic is really focused on advanced air mobility, and CAE sort of has stood up an organization since last September to focus on this new and emerging market. Our two speakers today, Chris Courtney is Director of Advanced Air Mobility at CAE. He joined the company in 2021. Chris serves as Director of Advanced Air Mobility at CAE with a vision to bring innovative high-tech training and operational support solutions to build the aviation workforce of tomorrow for advanced air mobility. Before CAE, Chris was head of flight operations at Uber Elevate, commercial flight operations lead at Joby Aviation, and operationalized a nationwide unmanned aerial systems company from scratch. He has also served 20 years in the US Army and Coast Guard as a senior aviator, instructor pilot, and leader, and has accumulated more than 3,000 hours of helicopter time. Tim Schotenauer, Director of Flight Training Global Solutions at CAE. Tim contributes at CAE in several capacities, primarily around aviation learning solutions and advanced training programs with specialization in competency-based training programs. Tim has held many positions in the past 25 years in aviation, including GCAA FCL Inspector in the UAE, Head of Training Etihad Flight College, Director of Flight Operations, and currently Global Director of Business and Helicopter Training at CAE. Okay, over to you guys. Thank you.
Thanks, Ken. I appreciate that. And thanks to all who have dialed in, and appreciate your time. So we are at an exciting inflection point in aviation and mobility. We all know that across the globe, companies are leveraging new technologies to create radically different aircraft designs that will enable more freedom to maneuver in cities, towns, and communities. Last month, we released our pilot training for advanced air mobility report to open the conversation about training and the importance of planning for training well in advance of the aircraft type certification and entry into service. I would like to thank the Vertical Flight Society for giving us the time to talk about the report and how CAE intends to lead and help operationalize this new form of aviation transportation that is going to provide efficient, quiet, and sustainable mobility solutions for us all. If you could go to the next slide, please. Yeah, so on the agenda here, guys, I'm gonna give you an overarching view of who CAE is and what our depth and breadth and our footprint looks like. Our mission statement for advanced air mobility, perspectives on the pilot landscape and the advanced training processes, challenges of developing an eVTOL pilot training program. Tim's gonna start to chime in on some of these training elements. Embracing modern learning techniques, structuring an eVTOL training program in the CBTA approach, CAE's 7-step model to unify the industry, and a timeline into launching a training program at a high level, what that looks like, and considerations beyond training. Go to the next slide, please. So CAE at a glance, and who are we? Well, CAE has 3 major verticals: civil aviation, defense and security, and healthcare. Largest civil aviation training network in the world. We have over 170 aircraft, 300 full flight simulators, 60 training locations, 1 million hours in annual training delivered, 135,000 pilots that we train every year. And CAE also graduates 1,000 cadets out of our flight academies. And so what's interesting in addition to that is on the defense and security side, those may not be aware, but literally last week on the 2nd of July, we acquired the L3 Harris military training business, which is the largest acquisition in CAE's history. And that dramatically increased the size of our defense business, providing training and mission support at more than 120 sites globally. And they are delivering 60 plus products and services to more than 60 countries. And essentially, we are the world's largest provider of military simulators. As an aggregate in the whole, CAE has sold almost 80% of sims throughout the world and trained a majority of the world's pilots on our devices. So why does that matter for advanced air mobility? Well, we've got 70 years of experience of certifying training programs, of training pilots, and doing all kinds of things, which I'm going to talk about in a bit. We've got the depth and breadth to help a lot of the players inside advanced air mobility be successful. We're a training provider that's going to be around for the long haul, and our worldwide footprint makes us uniquely positioned to help all the OEMs and operators that I was just kind of alluding to hit their business objectives in this new innovative space within aviation. Go to the next slide, please. So, yeah, we truly are a one-stop shop technology and service provider that provides end-to-end capabilities supporting safety and readiness. Going clockwise from the top on this particular slide and on that high fidelity simulation and immersive technology, as mentioned earlier, we've got over 70 years of experience to deliver training, simulation, and immersive tech. And then clearly in aviation, but also we are multi-domain. So on the defense side, we're in air, maritime, land, cyber, space, and public safety. And we are always innovating as a company. Moving over to student-centric training solutions. As mentioned earlier, we train more than 135,000 defense and civil aviation crew members each year, always tailoring our training around the modern learner. We have our CAE Tracks Academy powered by CAE Rise, and that stands for, Rise stands for Real-Time Insights and Standardized Evaluation Training System. Integrates technology, tools, and digital courseware into 3 training segments, and it's really tailored for the modern learner, self-paced, student-centric. Those 3 training segments are the Learn piece, which is tablet, laptop, Practice, which is virtual reality and mixed reality training, and Perform, which is with high-fidelity training devices or in-aircraft training. So on the pilot tech workforce resourcing side, through our Park group, access to the world's largest database of aviation flight crew and technicians. Essentially, I have over 45 airlines supported in the last 5 years through Park Aviation. Provide flight operations management and ground operations support, including recruitment, training, planning, crew operations management, pay and benefits. And we provide asset management support, including aircraft entry into service and continuous airworthiness management and exit from service as part of that particular offering from CAE. And we'll talk later about why that's important, but that's that element of the business is really helpful for OEMs with their global business objectives when they want to be in multiple countries, standing up operations. On the engineering sim and cert support, most people may actually not be aware of this, but since the early 2000s, CAE has leveraged advanced simulation to reduce airworthiness flight tests for some of our OEM customers. We've done this by implementing systems, integration, and testing into virtual environments as a parallel workstream to traditional testing. Anything from digital engineering environments to testing subsystems to actually creating full test rigs of an Ironbird of an aircraft integrated to hardware-in-the-loop environment to verify conformity with airworthiness requirements and flown without leaving the ground is some of the things that we've done to help accelerate certification programs. Proven that it can de-risk aircraft program schedules, manage development costs by identifying integration issues, prove failure modes early, and ultimately, as mentioned earlier, accelerates aircraft development. And this is an offering that CAE does as well. On the mission planning tools side of the house, we have software tools in our flight operations, crew tracking, and training elements for aviation operations. We have mission rehearsal tools with deep expertise in creating single synthetic environments, which is a replication or digital twin of an operating environment at scale with complexity that's never been seen before, never been possible before, excuse me. Basically, you can build a replication of an operating environment, say the size of an AAM launch market, couple this with multiple aircraft simulation devices, and you can see how this can support planning, training, experimentation, and mission rehearsal for new advanced air mobility operators. We are always making sure our customers have the edge that they need to be successful, and this is very applicable in advanced air mobility operating markets. On the RPAS side there, if you see in the top left where it says leading provider of RPAS training, on that element, CAE designs, develops, and delivers more remote pilot aircraft and unmanned aerial system training solutions than any other company, and that's in our defense and security space. And that we believe will be pretty applicable later on as advanced air mobility looks way off into the future to potentially pull the pilot off board the aircraft, but that's a ways out. And in the center, tying it all together, we're there for our customers every step of the way. Whether it's pre-aircraft certification, operational execution, we're there lockstep with them. And we are engaged with all the major civil aviation authorities. And from the AM side too, in addition, we're engaged with multiple industry groups, GAMA, HAI, VFS, and others to really help shape this industry. And we're serving on multiple committees and panels within advanced air mobility. Next slide. Okay, As you see and heard in the previous slide, CAE is positioned as a high technology company at the leading edge of digital immersion, providing solutions to make the world a safer place. That's one of our big taglines. Safety is everything in aviation, and this is no different for the advanced air mobility space, and even more critical for this brand new industry that is just beginning. Mitigating risks through timely and effective training designed and implemented by subject matter experts like CAE is incredibly important because if one mishap occurs out of the gate in this industry, it can set it back for years. We're all in this together, and it's imperative we collaborate and look at this as a preventive versus reactive lens so we can deliver on the advantages of electric VTOL aircraft that have to offer for the entire world. Ultimately, our mission statement for the Advanced Air Mobility Group is to provide electric vertical takeoff and landing, training, engineering, and operational solutions for private and public entities worldwide in order to shape the next generation of pilots, maintainers, and operators to fly clean, quiet, and revolutionary aircraft. Our group is nimble, and we look at ourselves as, say, the disruptors inside CAE, working with the disruptors in aviation and advanced air mobility. We know that we are working with non-traditional OEMs. We like to tailor our offerings to whatever our customers need in the advanced air mobility space, and working with folks that aren't your traditional aerospace aircraft manufacturers. These new entrants into aviation that are making aircraft are moving at lightning speed, and they need folks that can be nimble and can adapt to their needs. And we're there to be good partners, flexible, and work lockstep with their needs. Ultimately, it's our vision to lead the most progressive and adaptive aviation workforce learning experience in a generation in order to positively change the way people and product move by positioning ourselves as a leading advanced air mobility training and service provider. Next slide. Yeah, so ultimately, we are at an inflection point within aviation, and there's an unprecedented need for a sizable electric VTOL pilot workforce. There are some reports out there that show that we may need 60,000 pilots by 2028. Even if that's wrong by 50% or delayed by 4 or 5 or 6 years, that's still quite a bit of pilots and operators for the advanced air mobility industry that's going to be needed. And that's in addition to already large numbers needed for your traditional aviation, commercial aviation business. And so the way it looks for us is that the initial advanced air mobility pilot cadre, as this thing rolls out, will be experienced commercial pilots from both the fixed and rotary wing communities. Both those skill sets are very much needed for this space. As you can imagine, we've got aircraft that are vertically taking off in confined areas, transitioning through the national airspace system over a city market, and then landing in confined areas, which is what we talk about here with eVTOL pilots are going to need additional skill sets to meet the unique capabilities, designs, and operational environments that they're going to be operating in. And next slide, please. Yeah, what's interesting with the operating environment, shorter cycles per mission. Roughly the way things are shaking out right now, it appears to be 5 to 30 minutes for a mission duration. eVTOL pilots could experience 2 to 4 critical phases of flight per hour compared to what a traditional airplane does in a general day. We know that the aircraft will have limited battery life, and there's a lot of new things that are going to have to be discovered and planned for when it comes to infrastructure, when it comes to mission planning. We know they're going to be operating congested airspace, a lot of the markets, the launch markets that a lot of these OEMs want to go into have high density airspace, busy radio transmission, requiring more agile decision making and communication. A lot of the vehicles we know have a lot of safety features, built-in safety features to help it like that. But the industry will, start out in traditional means, as we've seen like in the helicopter space. Urban environments mentioned there as well. You're going to have micro weather, comms, dead zones, and I mentioned earlier about landing in confined and intracity locations, and emergency procedures over in near populated areas. They're going to have to be planned for in ConOps and so forth. So the operating environment, when you start to add more vehicles, becomes complex, and we have to train and plan and rehearse for all of these things. So I'm going to start to transition over to Tim. So he's going to start to talk about some of the training challenges associated with the space.
Excellent. Thanks, Chris. Good afternoon, everybody. I just wanted to remind too that if you have any questions, please feel free to enter those in the chat, the questions tab on the GoToWebinar dashboard that's available for you too. And as they come in, just start to jot them down. But in addition to the operational challenges, there's certainly a lot of training and regulatory challenges that exist. And as Chris really well defined, CAE's got a long history and legacy of supporting our customers and really transitioning to training solutions for solving some issues. And where there is a lot of ambiguity with eVTOL, there certainly is a need for it. So, specifically, there's 3 categories there: regulatory, single pilot operations, and some device challenges, just to mention a few. This is definitely not an exhaustive list, and those who are familiar with the industry are well aware of these challenges. But as a high-level summary for the audience, I guess as some takeaways from a regulatory perspective, there's undefined regulatory requirements that exist from 2 of the major NAs, which is EASA, the European Safety Administration, as well as the FAA, our agency, I should say, as well as the FAA. And we're kind of seeing a little bit of discrepancy between the 2 on both the short-term and the long-term solutions. Legacy regulation is going to have to bridge the gap in the short term. Rulemaking takes between 5 to 10 years, sometimes longer. And what seems to be what we keep hearing is that there'll have to be exceptions or exemptions to existing regulation in order to accommodate eVTOL and the OEMs that have ambitious targets for entry into service in the next 5 to 10 years. So some of that ambiguity on less so on the airworthiness side, maybe a little bit more so on the what they're calling aviator side, what they used to formerly say is airman side or pilot training through flight standards. They're now calling aviators, and also some as well on the definitions as far as how these vehicles will be categorized. So there needs to be that short-term and long-term approach. EASA is taking a look at something called an automated pilot license, which could be both a good short-term and long-term solution. And the FAA is taking a look at their existing category and class structure of aviators in order to provide some clarity for OEMs as well as pilots that want to transition to eVTOL. And another one of the major challenges is that these are single pilot operations in most cases. So where in traditional full flight sims, you've got a crew environment that needs to be considered. What does that do to the training elements and requirements when these pilots will be single pilot? And how do we monitor or provide check assurance for qualification checks to CAEs or authorities in order to qualify these pilots, knowing that, of course, the long-term outcome is that things will go autonomous. And then, of course, some device challenges, and by device challenges, I mean flight simulation training devices, those FSCD devices that logistically, in order to deploy a very large footprint for the OEMs that wish to operate in many different geographic locations, we need to be agile and be able to train pilots with various backgrounds. Chris has a background as a rotary pilot, and I've got a background as a fixed wing pilot. We both have different skill sets that can complement eVTOL, and there's probably less of a bridge for a rotary pilot to go towards eVTOL, and maybe a little bit bigger of a bridge for a fixed wing pilot to transition to eVTOL. So knowingly going into this with an agile methodology that we'll have to develop unique programs for the skill sets of where pilots are transitioning from is really important to do. And which device, and what the qualification that device happens to be is also ambiguous. But I've got some more information on how we can try to provide some clarity in the next few slides. So why don't we move on to the next slide and just simply acknowledge that every brain is unique, and CAE certainly has been spending a lot of time and money specifically on a learning science journey. We acknowledge that every brain is unique, and in order to overcome some of that cognitive conflict, we've got to encourage active learning using a lot of different techniques. Gamification, use of virtual reality, use of mixed reality are all elements that have come up just in this last 5 years or so as compared to the 50 years or 5 decades worth of legacy learning in the aviation industry. And it's important that we stay in front of that because innovation and technology certainly is changing as we drive towards making a case towards automation. Embracing these modern learning techniques is now more than ever extremely important. In addition, or trying to manage change, I should say, data becomes key. And that's probably the biggest takeaway on this slide is the need for us to be able to gather, collect, and use data in order to support the change that we're proposing, both on a pilot certification standpoint and the training programs that are being proposed, as well as device qualification standards so that we can get towards a more consistent outcome. One of those tools, just one example of those tools, Chris had mentioned earlier, is CAE Tracks, which, if I could just paint a quick mental picture, is essentially a fidelity, lower level fidelity device that is a chair, uses virtual reality that allows a pilot to practice and to learn, practice, and then complete different tasks in a very modular form. And that's been traditional pilot training for many, many years, is a very task-based foundation that leads then to more complex learning as those tasks are absorbed. And Trax does a great job of that. Another example is CAE RISE, which stands for Real-Time Insight Standard Evaluation, which allows us to capture some of the data that comes from training devices so that we can see what the overall trends are for performing that task in a simulation training device so that we can justify or advocate the level of fidelity of that device is sufficient or maybe more improvement in training that specific task. So when you break it down into those foundation elements of how to develop a training program, where to gain the data from the program, it really does start to evolve into the justifications to validate and justify change. So we really feel that the use of data analytics is going to be key in managing change that's required to justify for the industry with eVTOL. Next slide talks a little bit about CAE's approach on how we're developing the training programming for eVTOL. I've spoke with VFS before and have tried to outline the approach. This is an ICAO or an international approach that we're taking on the pragmatic design, instructional design process, which is called competency-based training and assessment. The CBTA process allows us to focus the pragmatic training design based on industry best practices that are international, keeping in the same mind of the global deployments of simulator devices. These training programs will also need to pass other Civil Aviation Authority approvals. So instead of developing a bespoke program for EASA or for FAA or Transport Canada or CAM or any other CAA around the world, by following one internationally recognized process, we're able to meet those expectations on the front side. So that's the reason for following the CBTA process. High-level summary, what is competency-based training and assessment? There's essentially 8 per ICAO or 9 pilot competencies. You can think of them as characteristics or fundamentals. You can also think of them as buckets of pilot performance. Fundamentals such as leadership and teamwork, decision-making, situational awareness. Some are technical buckets and others are non-technical buckets. But by keeping it contained to only 9, we're able to really provide some analytics and some feedback to pilots if they have some real takeaways on where they have opportunities for improvement. So the CBTA process really works for us. It allows us to also provide, where we have additional challenges, such as a lot of the bespoke vehicle designs from OEM to OEM. It allows us to develop a program that is characteristics, fundamentals, standards that are referenced. Then add
Hi, Tim. Are you still there?
Jim's here. I think we lost.
Chris is here. I think we may have lost Tim.
Okay.
Let me try to, he may have to call in here. Let me just ping him real quick. See if he's coming back.
Yeah, I don't hear him either.
Okay. Froze.
A reminder to all attendees, please enter your questions into the chat, which is take an opportunity to remind people. Please enter your questions into the sorry, not into the chat, into the questions section. Thank you.
Yeah, while we're waiting, do you want to address a couple of questions that have come in?
Sure. Okay. Okay, we've received a couple of questions so far. And I guess, Chris, you'll I guess do the part one, and if there's stuff that we'll ask the same question of Tim when he gets back.
Yeah.
Okay, first question comes from Charles Alcott of Future Flight NAN. Has CAE started to develop simulators for eVTOL aircraft? Will these need to be fully type specific?
Yes, so we are in the process of exploring and looking at and creating mixed reality simulators that are going to be applicable for the advanced air mobility space. We recognize that these devices will obviously need to be qualified with the authorities, and we'll have to work with particular OEMs to make that process work. But we are committed to doing that. We recognize that the advanced air mobility space is requesting a new approach to training, and we look at the space as a clean sheet opportunity to move into that particular segment.
Now, CAE announced a partnership with Jaunt, or a relationship with Jaunt. Was that focused on developing flight simulators for piloting, or was that something a little different?
That announcement was focused on engineering simulation, some of the stuff that I had mentioned earlier on that CAE has been involved with to help accelerate the certification journey for folks. And the press release with that spells that out. So anyone who wants to look it up can just look up Jaunt and CAE, and you'll see what I'm talking about.
Okay, we have another question from Kelsey Reichman from actually, I forget her. I'm sorry, I forgot her affiliation. But she's asking, what would you convince pilots? How would you convince pilots to get into this field, knowing that their role may be eliminated in the years to come as autonomous aircraft enter the industry?
Yeah, it's a great question. It's a fair question, and it comes up quite a bit. This is going to take some time before the authorities are going to approve and community is going to accept remotely piloted aircraft with human beings flying on the back without a pilot up front. I think it would be foolish to put our head in the sand and think that that's not where the industry is going, because everyone's been talking about it from an economic standpoint, that's where they're going. In order to encourage folks to get involved, we're 10, nobody really knows. We could be 10 years out, 15 years out before full widespread adoption of remotely piloted autonomous aircraft occurs. I look at it too as opportunities for folks that are either retiring out of the airline industry that want to fly these aircraft, and we really could use, in my opinion, we can use a lot of experienced airmen to operate these things in those early days, or a pathway for folks that are coming into aviation that could fly these aircraft, acquire necessary time, have strategic relationships and partnerships with airlines, and ultimately become a feeder for an airline before that happens. And then at the end of the day, when that transition happens, 10 years or whenever, you're going to need skilled operators on the ground that that can help manage and operate these aircraft. But we are a long ways out from that occurring. There's plenty of opportunity, in my opinion, for the next 10 years plus to fly advanced air mobility aircraft, electric VTOL aircraft for advanced air mobility.
Okay, remind our audience, please enter your questions into the question section. I have another question here, and hopefully Tim will be back with us soon. This comes from Louise Eric Mongrain, and I'm sorry if I mispronounced your name. He's asking, what role will the AAM pilot have? What responsibilities currently held by traditional airline or helicopter pilots will be delegated to the automation?
That is going to be vehicle specific. Hands down, you need a competent, qualified pilot that's making those aeronautical decisions that need to be made in the national airspace system. And frankly, most likely in very busy airspace, if you look at some of the markets that some of the OEMs want to go into. So that skill set, those requirements to operate the vehicle, operate the aircraft are still all there. Yes, there is some automation. There's a lot of automation in these aircraft, no different than there's a lot of automation in commercial aircraft, where essentially a pilot takes off on the controls and then it's nabbed up and the aircraft's on autopilot, essentially flying to its destination. And whether they auto land or take control, it's no different than what the commercial airline responsibilities are now. I think what is different and unique for the space, and it's what we commented on earlier, is that you do need some of the skill set of a rotorcraft pilot to be in the repertoire of folks that are going to operate and take off from confined landing areas and takeoff areas, down local on the ground or on an elevated building. There are just unique skill sets and concerns that are associated with that. Wind patterns and all the things that occur in our national airspace system are still things that a pilot is going to be responsible for flying that aircraft safely and delivering the cargo or the passengers from point A to point B.
And I'll just sort of add on to it. If the question is really talking about SVO, simplified vehicle operation, is there any more you can add when you hear OEMs talking about embracing an SVO approach? Is there where they're talking about phasing in or different levels of automation? Is same the answer, or is there something more you can add about SVO?
Yeah, I mean, there's plenty of envelope protection built into the aircraft. It'd be very, very difficult for a pilot to manage, say, 18 motors, flap configuration, and all the things that you would need to manage to operate an aircraft. And these simplified vehicle operating principles help take all that guesswork out of it, all that manual concern out of it. And with that envelope protection, it protects the pilot too, keeps the pilot from putting the aircraft in an unusual or bad situation. So that automation is designed to basically put the pilot in bubble wrap, is what I like to say. But you still need somebody that can make competent decisions in the airspace system. But that automation is designed to take all those manual tasks and essentially give it to a computer.
And the second question from Louis Eric, how do you foresee the transition from piloted to autonomous operation? Will tasks be gradually delegated to automation remote pilot on a GCS overseeing multiple advanced air mobility aircraft?
I guess the short answer is we don't know. One could speculate and guess. That seems like a logical approach where there'll be a remotely piloted system, somebody managing that aircraft and managing that aircraft off board. And then, once we get good at that, the authorities get comfortable with it, the data is there to prove that it can be done safely. maybe we're at a position where we can add multiple aircraft. I think what's going to be just amazing, dramatically different is that our past remotely piloted aircraft systems, for the longest time, we've been flying with sensors or cargo or ordnance from the defense side of the house. Not a lot of experience with like putting your son or your daughter or your mother on the back of that aircraft. And there's a quantum leap that's going to have to occur there to allow that to become viable and to give folks the confidence that it's going to be needed for that to be successful.
We have some more questions coming in. I'm wondering, Chris, with the balance of the presentation that we have, which was sort of core to your presentation here, I don't know if we have the ability to get Tim to call in by phone and brief us.
Yeah, he is. He's trying to call in right now. I'm just going to send him a quick note here.
So if he can call in by phone and maybe fly blind, but we'll guide him and bring up each slide as required. That would be just to add the value of your core presentation.
Yeah. He's. We'll keep stalling until he gets on, but
we're not going to stall. We're going to keep asking questions. We have another question from Charles Alcott, and let me read it to you here. From your interactions with would-be eVTOL aircraft developers and operators, will they be covering all the costs of training, i.e., as opposed to pilots having to cover the costs themselves? As a business model, will this be similar to how CAE provides training to airlines or business aircraft operators?
It's a great question, and there's obviously multiple models that can be pursued. I think one model is, I think what was mentioned there in the ladder, which is, a training provider like CAE that is deployed in a particular market, working with an operator, where we're, we are a business, so we would make our revenue from pilots flowing through our training programs and our schools and the spots where we provide that training, where the operator has to pay a certain cost or the OEM to make that training happen for a pilot. So there's just different economic models to pursue and follow, and I don't know which, everyone's got to. I want to say it's choose your own adventure. Certain folks, they've got different approaches to how they want to tackle that. I don't know if that's helpful if I answered the question, but happy to try another take at it if needed.
Again, I encourage people to put more questions into the box here. Let me ask a question of my own.
Looks like Tim's back on.
Okay, great. So we'll bring back the slides then.
Tim, can you hear us?
Sorry, Chris. I know I'm going to hear about this one. Yeah, I can hear you.
Tim, we lost you at hello, man. Start over.
No way.
So we have the competency-based CBTA slide up, which was slide 9. Is that what you want? I'm going to sign off here, but we want to make sure you're on the right starting point to carry on your presentation.
Sure. Did you continue, Chris, on slides below this, or not so much?
No, right where we lost. I started fielding questions, so it was great. I've been answering questions and just waiting for you to be able to rejoin us.
Okay.
So you can pick.
Sorry for the technical difficulty. Hopefully it continues. I hope I didn't have a frozen face. That was less than awesome, but nonetheless, we'll continue. So I'm not sure where I left off on this slide, but I'll just pick it back up again. But CBTA is the process that we plan to follow with eVTOL training program development, and the main reason why is that it's an internationally recognized process that allows us to write a training program once instead of several times for different NAAs around the world. EASA, FAA, Transport Canada, all CAs around the world that are member states of ICAO recognize this process as a pragmatic way of going forward, and it affords us additional opportunities. CBTA is really just an envelope that applies to a lot of different aviation disciplines and allows us to develop ATC training programs or even maintainer training programs, but in this case, pilot training programs. It also allows quite a lot of agility inside of the development of the program and takes it down to a very pragmatic level. So all the way down to a task-based level so that you can break down the training program and those building blocks and then build up from there. And essentially try to develop what is a generic eVTOL training program, but yet still have the agility because of all the different eVTOL OEM training designs to add in that specific or specificity of the training program itself. The CBTA is really founded, or the fundamentals of it are around 8 ICAO or 9 EASA competencies. And you can think of a competency as a characteristic or a fundamental or a trait that a pilot should possess. Just a couple examples of those would be problem solving, decision making, situational awareness, workload management, and teamwork. Those types of elements are pilot competencies. And that's what comprises, in addition to several others, 5 others, really the core skills of what a pilot should do. Some are technical, which is how a pilot flies a vehicle, and others are non-technical, which is how pilots interact. And even though these eVTOL vehicles will be operated single pilot, they'll still have access to a lot of company resources, air traffic control, and integration into the National Airspace System, and of course, to make a methodical decision-making process in their own brains because of that single pilot capability. So CBTA really allows us that opportunity to have a global training footprint delivery program and be able to apply it to different CAEs. The next slide, we'll talk about a 7-step process that CAEs identified that hopefully is high level enough that will allow us to be able to meet the OEM vehicle designs. But step number 1 is, of course, collect some data and science. You know, there's any benchmark data of science can be applied. So we first of all try to find scientific articles and research to help validate the science and the training technologies that we're trying to investigate. You know, surrounding or adjacent careers or I should say even fields such as medicine and how they're using VR and MR technology, not only in surgeries, but in training doctors and nurses, certainly helps us validate and benchmark against other credible industries. And that data and science collection is really key for us. Step number 2 then is to leverage a standard and determine what applies. EASA, FAA, any CAA around the world has identified aviator standards, and those standards are typically represented in some type of practical training standard that needs to be met by a pilot and can eventually get even as individual or bespoke as a specific training program. But by going through those standards, as I mentioned earlier, in the short term and in the long term, but in the short term context, it's important that we take a look at the standards to build that bridge of legacy regulation and where things are going to take us in the longer term future to provide that safety net, if you will, of standards so that the authorities are relieved, and which ultimately they're concerned for general aviation safety, and so are we. But at the same time, we have somewhere to work forward from as far as the developmental perspective. So really important that we have that safety net of leveraging those safety standards. Step 3 then is to document the difference. And really you're providing or you're conducting a gap analysis on for example, fixed wing air crewman standards to rotary wing PTS, practical test standards in some cases, and even possibly RPAS or remotely piloted vehicles, so that we're casting a net to determine what is the gap itself to develop what I mentioned earlier, which is that generic eVTOL task list. And then after that, we can conduct another net casting, which is what are the OEM vehicle differences and how can we incorporate that into the training programming. Step number 4 is again inside that CBTA process, but this helps us identify the best way to train those tasks. Once you've identified the task list and what should be trained, Now this is where we can start to apply different technologies to try and find out what's the best way to train those tasks. And each brain is different and unique. So training tasks in a different way is really important for us to explore and to test out. For those who are used to very technical documentation, I'll just mention the number about ICAO Doc 9625, and the tables that are inside that document give a real good indication of what's the device fidelity that's required in order to train a specific task or introduce or train to proficiency. For those not familiar with that technical document, just think of determining the best way to train tasks as just a beta test. If you've got to train a specific task such as transition, what are the elements that we can try to train that, and you kind of train it to failure, and you come back from that, of course, and determine then what tasks can be trained in which environment to which appropriate level of fidelity for a training device. Because eVTOL is new, because the industry is new, because the vehicles are new and don't have as much data, this training analysis and data collection really helps validate the training program for consideration with an authority. The data piece of this is just absolutely key in determining not only what devices that we conclude on can be trained for these tasks, but also what that training program composition looks like. Step 5 is almost really ongoing, but at this point it's more a milestone to have a formal risk assessment. But really, risk assessment is an everyday feature, and it is completed every single day during this development process, because we're trying to always reach down to as low as reasonably practical that risk, so that's acceptable for managing this type of major change and introduction of eVTOL into the aviation industry. And then step 6 is what we're doing a lot, and the good work that VFS does and other organizations to help develop industry consensus standards. We do this in a fully collaborative manner where we really truly want to see more definitive way forward, so that benefits other OEMs, other operators, other training providers, so that we do have a more definitive way forward, so that business cases are justified and validated with some certainty, which is really what this industry is searching for and needing, where we have that gap in regulation from that short term to longer term. And then step 7, of course, is continuous improvement, right? It's the go, but always assessing and continually trying to improve this process and getting feedback from pilots, for example, that are going through the training program and working that back into the system so that it becomes a continuous loop of improvement. And on the next slide, we'll talk a little bit about a timeline, because timelines are really important from a planning perspective. Now, there's a caveat, which is the top line on the slide, that says this is a conventional aircraft manufacturer that typically launches a training program, and then the development of which takes between 36 months or longer from day one commercial operations. And some of the text here is really small, but from a writer's perspective, your readers want to have some takeaways as far as how long does it normally take in order to do this. And where we have some ambiguity, it's difficult for us to say definitively, this is how long it takes. So we use, again, benchmarks. We use a conventional aircraft manufacturer, which CAE has helped many, as recently as the C series from Bombardier, which was, of course, now from Airbus. We have a long history of helping operators and OEMs throughout this process. So on the far left-hand side, you can see it starts at about 36 months out. And in my, you'll probably pick up on a couple different major categories to this timeline. You can see there's some regulatory issues here. There's some aircraft certification or airworthiness issues. There's some operational considerations and some logistics all inside this timeline. And I want to leave some more time for questions. So I will, I'll stop here, and we'd be happy to take some questions on this timeline and hand over to Chris for the wrap-up slide on slide 12.
Yeah, thanks, Tim. And that probably makes sense to just take questions. So I know we're short on time, and I don't know if Tim and I can probably go over by a few minutes. So Ken, I'll let you take it from there.
Okay, very good. Well, thank you very much for the presentation and the level of detail here. Again, I encourage our writers, our reporters in the audience, or others to enter the questions into the question section. Picking up on Tim's last slide, which was the 36 months. Now, we have some OEMs targeting entry into service in 2024, 2025. So looking at the next 3 years, what should really be happening this year, next year, and the year and 2 years from now? It sounds like we're to support entry into service from a training perspective. And how are we doing? How are we tracking as an industry?
Tim, do you want to take the first piece of that, or I can? It's up to you, man. If you want to.
Yeah, no, I think it's a valid question, and I wish we had a silver bullet to let you know. I think from my experience, at least, a lot of the OEMs are very much rightly focused on their vehicle designs and making sure that they're meeting their airworthiness objectives. Really partnering with professional training providers seems to be a way to mitigate some of their risk on their entry into service goals, and that's what we're really trying here to explain is that OEMs are really busy raising money, trying to solidify their vehicle design, trying to meet their production objectives, and there's just a lot to be done in this short and compressed period of time. So from, like I mentioned, from the operations piece and trying to stand up and be able to provide to your customers the spool up time to train pilots, for example, or as well as the logistics of trying to manage a full operational schedule and also get the operational approvals from the CAE. It does take time, and I think that's the takeaway from that slide, is to think about going backwards on all the different logistics that an OEM faces, to start to line up for them, what they choose to manage themselves, what they might want to outsource, and in order to keep them on time. Chris, anything?
Yeah, no, that's great. I mean, I think what we recognize too is foundational training needs analysis needs to be done first, and that's the foundational piece that will build the entire training program. Once you do that, and training specification, and start to develop the courseware and get a very qualified training program that you can go to the authorities with, that takes a lot of time. And I'm not even talking about like a choice of an FTD. A lot of these aircraft are single pilot. They don't have 2 seats up front with dual controls. So that makes some more complications in this very bumpy market as we figure things out. And so these things can't be thought of at the last minute. It's really, really important if the OEMs want to get their aircraft into service on time, that they're thinking about this training piece 2 to 3 years out is what we're suggesting right now. We have been doing this for a very long time, so we just know what it takes to get there. And the last thing you want is like, hey, cool, we're getting closer and closer, and now we've got to figure out how to develop a simulator, a training program, and all these other things, and it's going to cause delays. And some of these companies are going public, and they've got investors, and they're broadcasting stuff publicly out there. You don't want the training program to be the reason why you're late hitting some of your business objectives. And then lastly, as mentioned earlier on in the slide, is that we have this global footprint all over the place in 35 different countries. We have brick and mortar locations in a lot of the launch markets that these OEMs want to go, and so we have the capability to facilitate that training and pick your city in the world to make them successful. So
I'm wondering if you guys could just speak to the relationship between aircraft certification and the certification of a pilot training program. For those that aren't familiar, is the pilot training program part of the aircraft certification? Are these 2 parallel tracks? Just how are the 2 related? Because we hear a lot about aircraft certification, but not about pilot training program approval or certification.
Yeah, they're separate efforts, but they can certainly be run in parallel. Milestones of the airworthiness program, of course, the OEM is trying to reach type certification in the vehicle. And a lot of times it's what they focus on, their engineers focus on is trying to get that across the line. And then, you know, I'm not sure I mentioned it as it was cut out there, but terms like type rating like or operations evaluation like, I think are appropriate here as EASA and FAA are still converging on their way forward. But that operations evaluation like process that many can connect with, I think is very relevant, certainly from a training perspective on what are the expectations from the authority to get the training program approved to fly these aircraft safely. Will they be looked at individually? Most likely, just like similarly to your point, Ken, on the airworthiness piece, they'll most likely be looked at individually. And then, you know, what are the requirements from a pilot certification standpoint from the CAA in order to support those pilots to transition into the operation of vehicles? So separate tracks certainly can be run in parallel, and they're both as important as each other.
Okay, please put your questions into the question box. Okay, here's another question for you. If we jump ahead to say 2025, 2026, and there is a pilot training infrastructure in place to support the early into market eVTOL OEMs, what do you think that will consist of? Will it be an airfield in Arizona with a bunch of eVTOL aircraft providing ab initio training, or is the training going to be at Marina Airport and, you know, to support Joby, or is the training mainly going to be provided where the aircraft are being rolled out into a marketplace like Los Angeles or Miami or somewhere in Europe?
Yeah, I can take that one. So, you know, from my perspective, it's a little bit of both, to be honest with you. Most likely and ultimately the initial training is going to occur probably close to where the aircraft's being manufactured. And then as those OEMs look at their particular launch markets, they're going to want to have training capabilities in that particular launch market. If you're an OEM in Europe and you're, you know, qualifying pilots in Europe, but one of your early markets is in Asia, you're going to want to have the capability to do training in Asia for that particular market that you're getting ready to launch in. And so there is definitely a need for both, if that makes sense. And again, going back to, you know, our global footprint, we're in a unique position to help facilitate that. So.
Okay. We have another question that's come in from Salim Zahir, and the question is, have you had any discussions on this with regulators? What are their initial responses to SVO and commensurate training?
Tim, you want to take that?
Sure. A lot of the OEMs have engaged the regulators to try and get some certainty where there isn't. Now, the question mentions SVO, Simplified Vehicle Operations, which is certainly an initiative that is happening in North America with the FAA, NASA, and others that are contributing to that. And SVO is very much that medium to longer term piece. And I think I'm going to turn off my camera because I'm getting warned again. My internet is not so bad. Can you hear me still?
Got you loud and clear.
Yes, we can.
Great. Sorry. So, and then, you know, really we're primarily making a larger effort on the standardization groups so that we have one unified message from the industry when it comes to engagements with the regulators. Now we've got well-established, you know, selfishly from a CAE perspective, we have well established roots with NAAs, and we're recognized as an innovation training leader with EASA. So we have a lot of very, you know, legacy relationships and strong relationships with regulators when that time is right to approach a regulator with a definitive plan forward.
Okay. I see we're over the 1 hour mark, but I'm going to throw in one other question here. Because you did talk, and I'm sure, Chris, when you were at Joby and with that Uber, the pilot demand aspect. how quickly are we going to need pilots, and what kind of numbers are we talking about in the sort of startup phase and a few years out? Is this a volume we can manage? Actually, that's a leading question. What are we talking about? Because I don't think when you talk about the scale of advanced air mobility operations in a major center where they would require hundreds of aircraft, what does that translate into in terms of pilot demand?
You know, I think and I am an operational guy, right? I have an operational background, and I know what pilot to aircraft ratios look like to do certain types of operations. So most likely you're to do an operation that maybe start at, I'll call it at 6 a.m. and go to 6 p.m. because a lot of these aircraft are probably going to come out of the gates VFR day right away, and then eventually move into night would be my guess. I don't know for sure. But to support that level of operation and just knowing how many hours and how many days a pilot could work, the math is there, would lead you to believe that you need about 3 pilots for every aircraft for the most part to fly at the rates that a lot of the OEMs are publicly talking about. So between 2 and 3 pilots, you can plan for that, and just, you know, based on an aircraft number that's coming out, you can start to do the math, and you can start to see where the numbers start to become exponential as the production rates increase. And as we all know, with these novel aircraft, which is amazing and awesome, is that they're partnering up with automobile manufacturers and folks that can really help, you know, really accelerate the production of aircraft. And so you can see as they produce a lot of aircraft, you're gonna need more pilots. But I also, you know, want folks to, you know, be real about this. There's got to be an appetite from the market to, you know, make sense to put an aircraft into operation that's going to go make money. You know, that's critical for the success of the industry. So long as the community engagement is done in advance in these markets, as long as the appetite's there to take these new forms of transportation, that just only helps fuel the need for more aircraft and more pilots. So there are a lot of reports out there that have a very shallow start, but I think once a proof of concept happens in a particular market where somebody's actually able to get a legitimate service that's reliable back and forth, and the public becomes comfortable, I see like that word gets out across the globe quickly, and people are going to want these aircraft in their particular city to help save them time and get them the mobility, the additional mobility solutions that people are demanding for right now. Long answer to your question, Ken, but hopefully it helps.
That's exactly. And the other, and I'll make this my last question. I don't see anything from others here. One, I guess I would also address people to look at your white paper, the pilot training for advanced air mobility. It's in the, it's that as an attachment. But the other question I have is, one of the other stakeholders is pilots themselves. I just spent a little bit of time on the West Coast, and happened to meet a lot of pilots in waiting, helicopter pilots who were working ground jobs hoping to fly helicopters. And most of the people I met, probably about half a dozen, were completely unaware of the eVTOL market. What do you think the attraction is going to be for a commercial pilot to fly eVTOL? And how did we get the word out there that this is a future career opportunity?
I think people are, I mean, there's so much buzz in this space. Like, it is the shiny new thing in aviation, right? And so, yeah, granted, some people may not be aware, and, you know, we're victims of our own, you know, of what we do in this industry, because we eat, sleep, and breathe advanced air mobility, electric VTOL aircraft, and not everybody's aware. But there's a big opportunity coming for folks. Yeah, I have to make sure that we also are mindful that Part 135 operations requires a certain hour threshold. And so, you know, you're going to need pilots to get to a certain hour threshold to be able to go fly for commercial operations on a 135 ticket or operating certificate. So, you know, it's something that we have to plan for and look at. Now, I do believe that over time, with data, that there may be a world where we might be able to lower some of those targeted hour requirements and thresholds on the 135. We're not there yet, and frankly, we shouldn't be. You know, we as an industry, we got to prove ourselves the authority that those type of, you know, new ways of thinking make sense. So, which if that does, and that could potentially even bring a much wider net of more pilots that could come into the system. Because I really believe, we're trying to inspire the next generation to come to aviation and come to aerospace. And I think there's a path there for them.
Will these aircraft be fun to fly?
I think so.
Yeah, from a true attraction to a pilot perspective, a lot of pilots, they go longer distances and they're going away from home a lot. So with eVTOL, if that's your operation, you operate out of one hub and you pretty much are home every night. That offers a new type of quality of life that wasn't there before. So I think as the operational environment comes open and we start to see what it looks like for where these pilots will operate and what that quality of life also looks like, it definitely would be attractive for many.
Very good. I've got one last question here that came in through the question tab from Slim. So here, what would the baseline qualification be for a commercial pilot license, and then get a type rating on the eVTOL platform?
So the underlying fundamental license requirements right now are exactly as they are in EASA or FAA. So if you're looking for a commercial pilot certificate, you would just go to the baseline requirements from experience and aeronautical experience that's required for that certificate or rating. The word type rating per part 1 in FAA context definitions, eVTOL doesn't meet the weight requirement, and it's not a turbine aircraft, so it may not require a type rating. That's why I say type rating like and operations evaluation like, because it creates an immediate association with pilots. And we'll absolutely come back to you when we have more information on what are the requirements for example, a fixed wing pilot transitioning to an eVTOL model or rotary wing pilot transitioning to an eVTOL model when we've got that all mapped out. So I look forward to showing that on in future calls as we have that definitive.
Okay, Tim, you were cutting out there, but okay.
We caught it though, we're good.
With that, we'll wrap this up. Again, I encourage our viewers and those watching this later on the recording to check out the CAE white paper pilot training for advanced air mobility, which was published on June 1st. And hopefully we'll have CAE back at another of these events and at our functions and forums as this industry progresses. Thank you very much.
Thanks everybody for your time. Thanks Vertical Flight Society, really appreciate it.